Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over volume of pyramids and cones. The nice thing is that these two formulas are the exact same. However, there's one variable that is going to consistently change depending on the base shape. So diagram shows a square pyramid, a rectangular pyramid, and a triangular pyramid. So notice pyramids, their sides, their lateral faces are all triangles, but the base shape can change. So it could be a square, it could be a rectangle, triangle, and so on. So the formula is going to always depend on that base shape. Now notice that the height is pointing to that dotted line inside the shape. So when we are finding the height of these pyramids, we want to find how tall it is from the vertex, the tip of that pyramid, straight down to its base, forming a 90-degree angle. So we do not want the outside, that slant, like we did with the surface area. We actually want the inside. So how tall is this shape from the top to the bottom, forming a 90-degree angle? So be careful when we try and find that height or use that H in the formula. So before you find the volume of a pyramid, you have to find the area of the base. So if it's a square, side times side, a rectangle, length times width, and then a triangle, base times height, and then cut it in half, divide by 2. So then you can use the formula below. In the formula, B, that capital B, remember, stands for the area of the base. So the capital B, it changes depending on what the base shape is. And then H is always the height that we talked about. So volume of a pyramid. Here is our formula. 1/3 times the area of the base times the height. So off to the side here, I'm going to write down so that you remember, and I want you to put this in your notes, that B changes, the capital B, and let's say depending instead of, I was going to write based off of the base, which would be a little confusing. So B changes depending on the base shape. So if it is a square, well, then we will use side times side. If it's a rectangle, we will do length times width. And then if it is a triangle, you can either do 1/2 times base times height, or you can do base times height, divide by 2. So that I'm pretty much going to narrow it down to those 3 types of base shapes. Now, also notice in your formula, the 1/3. Basically what this means is the same rectangular prism. So if we were to actually change those triangular sides into a rectangular prism, and I'm no good at drawing here. So what happens is we can actually take the volume of that pyramid and we can fill it up 3 times that will fit into that rectangular prism. So that's why we are using this 1/3. This is a repeating decimal of 0.3333, so on. So we cannot round it. We can't use 0.3. It's going to change that formula. So when you use this in your calculator, you can either do 1 divided by 3 and then click out front of it to multiply. And notice here that long decimal. Or we can do the area of the base times the height, so the capital B times the height, and we can divide it all by 3. That is the same thing as multiplying by 1/3. Same thing for the cone. It's the same exact formula, except for the cone, the base shape is a circle. So that capital B in this formula represents pi r squared. So capital B, our base shape in a cone, is always a circle. So the capital B in this formula, we're going to change to pi r squared. So that capital B always changes. You got to make sure you look at what the base shape is. So actually this volume of a cone, it's always going to stay the same. It's going to be 1/3 times pi r squared times h, because the cone, the base shape doesn't change. A pyramid, it could change, okay? So let's do this first example. We have a cone down here. I know it's hard to see. This is the radius is 3 centimeters, and then the height is 7 centimeters. So I'm going to show you again how we've been doing this, both methods where we get the exact volume and we also get the rounded volume. So I personally find it easiest to actually divide by 3, and I deal with that 1/3 fraction at the very end. So pi stays there. We know the radius is 3, so I'm going to replace r with 3, and we know the height is 7. So I'm just going to work with my numbers, and they're at the end here. So 3 squared is 9, and then I'm going to also multiply by 7. And I'm going to show you each step as I'm figuring out this volume. So all I did was actually 3 squared. Now I'm going to do 9 times 7, so we get 63. Now, to find the volume in the exact volume in terms of pi, well then I'm going to just work with my 1/3 and my 63. So off to the side here, I want you to show that 63 divided by 3 is the same thing as multiplying it by 1/3. And you could look at that in your calculator. Do 1/3 times 63, or you can take 63, divide it by 3. And look at that, you get the same answer, we get 21. I have done nothing with that pi, so this is our exact answer in terms of pi, 21, and then times the pi. Our label then, volume, is centimeters cubed. So this is our exact answer. And then lastly, we can take 21 and multiply it by pi, and we get 65.97. So if we're rounding to the nearest tenth, we'd actually round up to 66. So the volume is approximately 66 centimeters cubed, and that is rounded to the nearest tenth. So there is, again, the same 2 answers, just one is exact, one's rounded, the volume of that cone. Okay, let's go to the back side, and we have a couple more examples. One with a cone, and then we also have a pyramid on the back. So here is a party hat. We're going to find the exact volume, and we're also going to round and find an approximation. At this point, pause the video, follow the exact same example that we did on the front side, and see if you could figure out these 2 volumes. So we will use the exact same formula. So volume is 1/3 times pi r squared times the height. So in this example, we're going to replace the radius with 6. It is off to the side here. And then the height is 14. So we'll do 1/3 times pi times 6 squared times 14. And then take it step by step. We've got 6 squared is 36. Then 36 times 14 is 504. And then we could, and I'm going to double check that, 36 times 14, it is. And then 504 we can divide by 3. I'm just working with those numbers, kind of forgetting about pi. So volume exact is 168 pi. Oops. So here, the exact volume of the hat is 168 pi, and our label was inches, so it'd be inches cubed. And then last step would be to actually take that 168 and multiply it by pi, and that would be 527.8 if you rounded to the nearest tenth. So down here, I'm going to write an approximation of the volume of the hat is 527.8, and again, inches cubed. So there we did the exact same thing as that first example, just finding volume in terms of pi and then also rounding the volume. Next example, then we're going to do one with a square pyramid. So a square pyramid, here we have a height of 12 meters. If the side of the base measures 5.5 meters, what is the volume of the pyramid? So we know first to find the area of the base, we know a square is side times side. So we want to figure out the area of the base. Remember the volume formula is 1/3 times the area of the base times height. Now that capital B changes, and since this scenario is a square, the capital B is going to be side times side, or side squared, and times the height. So let's find that capital B first. We know that the side of the square is 5.5, so we square that. 5.5 times 5.5, so the area of the base is 30.25, and that's meter squares. We're just finding the area of the base. So now we want to substitute that into the formula and also substitute the height in and find the volume. So volume 1/3 times, we know the area of the base is 30.25, and we know the height is 12. And that was told to us in the problem where I highlighted up there. So at this point, you could plug it all in at once. Remember, you could do the 1 divided by 3, and then multiply by 30.25 and multiply by 12. Or you can do your 30.25 times your height, so the area of the base times the height, and then take that answer and divide it by 3. And you notice either way you do it, you get the same answer. You get 121. And here is showing your work. You can plug all that in at once. So the volume of this square pyramid is 121 meters cubed. Now this volume does not have the pi symbol. There's no talk of pi anywhere in this example because there's no circle. The square pyramid has a square base and then triangular sides. So no circle, there's no pi. So the volume is simply 121 meters cubed. So there's how we find the volume of a cone and a pyramid. It's the same process. Just be careful if you ever get a pyramid with a triangular base, you would find the area of that base. So base times height, cut it in half, then multiply by the height, and then also cut it into thirds, divide it by 3. So we'll get some practice doing some more of those volumes and